Okay, on to section 4, which is proof by deduction. So we've already looked at disproof by counterexample, but we're now on to proof by deduction. Okay, and a lot of words there. Basically, what proof by deduction is you're given a statement and you want to prove that something is true using an argument made up of a list of logical steps. Basically, what that means is you just want to use usually algebra, but it can be often including words to prove that something is true, but it's done in a logical order. Right, so more formally, the book puts it written as this, and we'll read it together because I think this is quite a nice definition. So it says, proof by deduction. To prove that a result is true, you need to start with what is given in the question, okay, and form a series of logical steps to reach the required conclusion. Okay, so you're given a question and you want to form some logical steps to get to the conclusion. And usually we use algebra to help us get there, but you can often use words or other means, okay? But algebra is a really important part of this. This bit is really important. We need to use algebraic expressions for different types of number, because when you're proving something by deduction, you've got to use algebra to prove something for all cases. So if you're writing even, odd numbers, square numbers, etc., you've got to be able to write those algebraically, because it might say something like, prove that if you times an even number with an odd number, it's always even. And you can't just go and say, well, 2 times 3 is equal to 6, 6 is even, I've proved it by deduction. That's not going to cut the mustard at AS. You've got to be able to write things algebraically to prove stuff for all cases. Okay, so let's get on to the key facts you need to know for algebraic proof. So you might need to grab a pen pad here and make a few notes, or you can just watch me go through it. So the first thing, right, if you've got even numbers, you can express even numbers as 2n, where n is an integer, a whole number, because 2n is just your 2 times table. If n is equal to 1, 2 by 1 is 2. If n is equal to 2, 2 by 2 is 4. It's just your 2 times table. Okay, so 2n represents your 2 times table, 2, 4, 6, 8, so on and so forth, okay? And your 2 times table are your even numbers. So that is a very useful thing. 2n are your even numbers. N, you don't have to use the letter n, but it's just what we use formally for this. Okay. Odd numbers. So odd numbers are always going to be plus or minus 1 below an even number. So you can write an odd number as 2n, so taking your even number and then either plus or minus 1. Because if 2n, okay, they were your even numbers like 2, 4, 6, 8, so on and so forth. If you go and plus or minus 1 to those, well, what's plus 1 from 2? It's going to be 3, plus 1 to 4 is going to be 5, so 3, 5, 7, 9, so on and so forth. Okay, the reason the 1's not there, if n is equal to 0, 2 by 0 is 0, add that 1 is equal to 1. So we use algebra to help us represent all of the possible odd numbers that we can possibly think of. Again, you don't need to use the number, the letter n, you could use a different letter. And actually you might need to in some cases that you'll see later. But for the time being, just know that's enough. For different odd numbers, okay, for 2 different odd numbers, we can use different letters, and this is important. So if you want one odd number, you can use 2n plus 1 or minus 1, that is fine. For a different odd number, we can write it as 2m plus 1, for example, because let's just say that n was equal to the number 2. For example, 2 times 2 is 4, add 1 is equal to 5. To get a different odd number, okay, I could use m. If I used n to be equal to 2, m is going to have to be a different whole number. Let's just use m to be equal to 10. 2 by 10 is 20, add 1 is equal to 21. So you can see here, I've got 2 different odd numbers shown by the different letters n and m. You could actually also do this a little bit differently. If you wanted consecutive odd numbers, you could write 2n plus 1 and then 2n plus 3. There's sort of different ways that you can write things, but I'm just keeping it quite simple for the time being, and that's going to be enough, hopefully. Okay, right, other multiples. This is really useful because often they might say in a question, prove that if you do something, you get a multiple of 4, for example. And how do you write a multiple of 4? For example, you would write it as 4n, because 4n, a bit like 2n, it just means you've got your 4 times table. So 4, 8, 12, 16, so on and so forth. This is a really useful thing to have in your inventory. Okay, similarly, if you wanted a multiple of 2, you could write it as 2n, so on and so forth. 5n would be multiples of 5. Okay. And finally, things like square numbers, cube numbers, all that kind of stuff. Right, a square number you can represent as n squared, a cube number n cubed, so on and so forth. Again, we're using algebra to show all of the different possible, in this case, square numbers that we can have. Okay, so let's get on to the examples now. Let's talk about this in a little bit of detail. So work example 1.7 says, prove that the product, so if you're timesing an even and an odd number together, the result is always even. So to think about this, it is saying if you take an even number like 2 and an odd number like 3 and you times them, it is always even, right? We can see with this basic example, 2 by 3 is equal to 6. But unfortunately, that is not going to cut the mustard. Okay, even if you went through 20 different examples, it's still going to cut the mustard because you need to use algebra, okay, so the logical argument using algebra, because that will cover you for all of the different cases there are. That is why we use algebra, okay, because it covers you for all cases. Right, the first thing with this one here, okay, so we've got prove that the product of an even number, again, how can you write an even number? We can write it, we've just seen, as 2n, and an odd number. And maybe you're thinking, okay, I can go and write this as 2n plus 1, and you're not wrong, but you just got to be a little bit careful with this because, right, if we use 2n and 2n plus 1, okay, you're actually using consecutive numbers, right? If n was equal to the number 1, 2 by 1 is equal to 2, n was equal to 1, 2 times 1 is 2, add 1 is 3, okay, it's a little bit specific. So we're using algebra, but we've sort of chosen here, we've chosen numbers that are consecutive, one after the other, and it's not great, it's not wrong necessarily, but it's just you want to make it as random as you possibly can. So instead of using, let's go to this, instead of using the same letter n, right, in this case we want to use a different letter, like something like m, because then if n and m are different numbers, you're getting two totally different integers. You're getting one even number and one completely different odd number that aren't consecutive. It's more random, which is good. Okay, and the question is saying if you times these together to get the product of them, you want something that is always even. So basically, right, you want to get to a stage where you can factorize out a 2 at the end, because if you can do that, then it's going to be even. So you factorize out a 2, there's going to be something in a bracket with a bunch of numbers, okay, and then that's going to be good. So there we go. That's the form of the question. Let's begin. So we take our even number 2n and we multiply it by 2m plus 1. I want to get to a situation where I can factorize out a 2 at the end. So basically, right, let's just go and manipulate this here and let's go from there. So we could expand the brackets. That's one way of doing it. So 2n by 2m and 2n times by 1. That's going to give us, well, 2n times by 2m is going to give us 4n m. It looks a bit confusing because you've got n and m. Just write it really clearly, particularly with me with bad handwriting. You don't want to get muddled up with your n's and m's. 2n times by 1 is going to give you plus 2n. Okay, and now here we said, right, the goal is to show it's even. I want to factorize out the number 2, which I can do here, which is perfect. So I can go and factorize out a 2 from both 4nm and 2n. If I do that, if I take out a 2 and open up a bracket, 2 times by 2nm gets me to 4nm, and then 2 times by plus n gets me to 2n. Okay, so 2 by 2nm gives me this, 2 by n gives me this, which is nice. Okay, and I've proven it. Right, I'll go into a bit more detail in a second, but basically, right, this here, n and m, okay, these are just numbers. Let's just say n was equal to 1 and n was equal to 2. Okay, so you've got 2 times 1 times by 2 plus n again, which is 1. You're just getting some number, okay? And 2 times by any number, whether it's odd or even, is always going to give you an even number, okay? So 2 times by any number will always be even. Try it. 2 times 1 is 2, 2 times by 2 is 4, 6, 8, it's always even. So really, just to make this a little bit nicer at the end, what I can just go and do is I can write this part here, okay, this is just some integer, some number, okay? Not necessarily an integer, it could just, yeah, an integer, sorry, it is an integer. So this here, I can go and replace it with another letter, like k, okay, and this k is just representing this number. This is just a number, and k is just making it a little bit clearer. So then I can go and say, well, 2 times by k, okay, I've just replaced this here, just a number, with k, okay, where k is an integer, Okay, so 2 times by some number, like 1, like 10, like 11, like 13, is always going to give me, okay, an even number, which is exactly what the question is asking for. And I've proven this for all cases, okay, because I've used algebra. Algebra covers you for everything. Okay, so for any even number times by any odd number, I can always factorize out the number 2, which means that the product of an even and an odd number is always going to be even. So I talked you through that hopefully in quite a lot of detail, and hopefully I haven't overcomplicated it, but I think it's important that we really understand what is going on here. Okay, example 1.8, it says prove that the difference between the squares of consecutive odd numbers is always a multiple of 8. So first of all, a few keywords here. What does consecutive mean? We're looking at consecutive odd numbers. Consecutive just means we're looking at one odd number following another odd number. So 3 and 5, for example. Okay, and it's saying prove that the difference between the squares of these consecutive odd numbers. Okay, so it's saying if I took the squares of these numbers, like if I went and did 3 squared, and I did 5 squared, and I took the difference, it is a multiple of 8. So let's just see if it works here. 5 squared is 25, 3 squared is 9, take them away, I get 16, which is a multiple of 8. Okay, but of course, this is not going to cut the mustard. Okay, proof by deduction, you've got to use often an algebraic proof, because that covers you for all different cases. That is one case. And again, you could go through 1,000 cases written numerically, it still wouldn't cut the mustard, because there could be one case which doesn't work. So you've got to use algebra. So we've got to be able to write this using algebra. So first of all, right, how do we write consecutive odd numbers? You could write it in different ways. Okay, one way of doing it is something like this. You could do like 2n plus 1. That's your first odd number. And then consecutive, if you write it as 2n plus 3, these are consecutive odd numbers. Because if n was equal to 1, for example, 2 by 1 is 2, add 1 is equal to 3. So if n is the same number, 1, 2 by 1 is 2, add 3 is 5. They are consecutive. That's one way of writing it, but usually we write this a bit differently. That's fine. And note also, this time I'm using the same letter, n. If you want consecutive numbers, you want to use the same letter. If you use m in this case, you're using a totally different odd number, which would make it consecutive. So in this case, we do use the same letter. I'm not going to write my numbers like this. I'm going to write them a little bit differently. Okay, I'm going to write them like this. 2n minus 1 and 2n plus 1. These here are still two consecutive odd numbers. Okay, if n was equal to 1, for example, again, 2 by 1 is 2, take away 1 is equal to 1. If n was equal to 1 still, 2 by 1 is 2, add 1 is equal to 3. These are consecutive odd numbers, they follow each other. And it's just usually the way that we write consecutive odd numbers. Okay. So let's just go through this now. So I now want to go and find the difference, which means I subtract them from one another. The difference between the squares of consecutive odd numbers, okay, is always a multiple of 8. So at the end, I want to be able to go and factorize out an 8 from what I get and get something in a bracket, okay, because then 8 times by anything is going to give me a multiple of 8. And I want to square these numbers here. Okay, and because this one's the bigger one here, to keep it positive, I'm going to do the bigger one squared, take away the smaller number squared. Let's go and do that. So, right, the squares, so I want to be squaring my numbers. So the first one, 2n plus 1 squared, take away, because that's the difference of my other square number, which is 2n minus 1 squared. And basically, right, I'm going to work through this, and I want to be able to factorize out an 8 by the end of it. So the first one, right, we've got 2n plus 1 times by 2n plus 1, and we're taking away 2n minus 1, bracket 2n minus 1. Hopefully our work on brackets is pretty good. I'm not going to go through the bracket bit in detail. If we expand this, we're going to get 4n squared plus 2n, so plus 4n, 1 times 1 plus 1. Okay, and we're taking away, and be a little bit careful here, the way that we write this. Really, I should probably write a bigger bracket so we don't get confused here. We're taking away big bracket, and it's going to expand this, so we're going to get 2n by 2n is 4n squared. 2n by minus 1 is one lot of minus 2n, but then we want it again, so minus 4n. We've got negative 1 times by negative 1, which is going to give me plus 1, and there we go. Okay, I've just expanded the brackets very quickly there. Hopefully that's not an issue. Okay, and then I'm going to go and use that negative and apply it to all of my parts terms in the bracket, and it's important that I did write this in a bigger bracket, otherwise you would get sign errors. Okay, so we're going to get overall just 4n squared plus 4n plus 1. Okay, and then we're going to be taking away that 4n squared. Okay, this times by this, negative times by that negative 4n will give me plus 4n. That negative times by that plus 1 is going to give me negative 1. And then there's going to be some cancelling going on here. I've got a 4n squared and a negative 4n squared that disappear. Okay, and I've got a plus 1 and a minus 1 that disappear. What is left? I've got a plus 4n and a plus 4n. Lovely. Okay, why is that lovely? Because 4n plus 4n is equal to 8n. Okay, written not particularly well, is equal to 8n. And perfect, right? This is going to be a multiple of 8 because n is just some integer, and 8 times by any integer will be a multiple of 8, okay? Because if n was equal to 3, 8 by 3 is 24, a multiple of 8. Okay, so 8n, okay, is a multiple of 8. So there we go. If we zoom out and hopefully get the whole question in, okay, good, we can see the whole thing, which is good. What's going on there? Okay, I've proven that the difference between two square numbers algebraically, so these are my two square numbers. I did the bigger one squared first because like that's going to be your bigger number. It makes a bit more sense. Is a multiple of 8, which we can see. Oh, what's happened there? Which we can see down there. So we had our algebra to represent all of our numbers. We then went through the algebra and we got to 8n, which is going to be a multiple of 8. Okay, that is it by proof by deduction. Any questions, please just answer in the comment section. Hopefully that was useful. Thank you.